This is Ms. Gallo with Unit 7, multi-step trigonometry problems. So our goal is to solve multi-step trigonometry problems to solve for unknown angles or lengths. So there's not much of a lesson to really go over here, but I'm going to just remind you of the tools that we're going to use, and then I'm going to do some model examples. These are going to be word problems. However, the pictures are going to be given for us. So we're going to be dealing with trigonometry, which deals with right triangles. So when we have right triangles, these are the tools that we can potentially use depending on what information we are given. So if we want to find sides or lengths, and we have an angle and at least one side, then we can use sine, cosine, or tangent. Remember, SO, CA, TOA is your acronym to remember the ratio side. So sine SO would be OS and O and H. Remember, we can also find angles where we would use the arc sine, arc cosine, or arc tangent, where we hit the second sine or the second cosine, depending which sides we are given. So we would need two sides to be able to use one of those ratios in order to find the angle. We are familiar with Pythagorean theorem, a squared plus b squared equals c squared. So we need to know two sides to use that. And we also have similar triangles. So if we notice in the problems that the two triangles we are working with are similar, then we can also use, or they meet angle criteria. Two pairs of angles are equal, one of them being the right angle and then another pair being another angle. Then we can use proportions as well. So always keep in mind that knowledge that we have about similar triangles and angle, we could use that as well. I don't know if we're going to use that today in any of these model examples. So here, a ship is sailing directly toward a lighthouse. So we have two pictures here, and we have to kind of figure out what we're doing. So let's first identify what they're asking us to find. So they said the ship was at A and looked at the lighthouse at an angle of 7 degrees, and then it was at point D, and then it looked at the lighthouse at an angle of 16 degrees, and we want to know how far did the ship travel between those two sightings. So this length AD right here, this is what we do not know. That's what we're looking for. So my plan here is to use two right triangles. So I'm going to redraw them. And because if I just use this triangle ADB, that is not a right triangle. That's an obtuse triangle. So I can't use trigonometry for that. I would have to use a different kind of formula, which we're not going over here. So I'm going to redraw two right triangles. I'm going to find the length of AC. I'm going to find the length of DC. And I'm going to subtract them to get AD. So AD will equal the longer one AC minus the shorter one DC, and that should get me to my answer. So first things first, let's draw these triangles. So here's my first one that I'm pulling from the picture. D, 16, 125, B, and C. So here's my first one, and I said that I want to find the length of DC on this one. DC. It doesn't matter which order I find AC or DC first. Not important because I need both of them to go further. Okay, so if that's what I want, DC here, okay, what do I have? I have a reference angle. I have the adjacent side. I'm looking for the adjacent side, and I have the opposite side. So opposite and adjacent, that would be TOA. So the tangent of 16 equals the opposite over the adjacent, which we do not know, which is DC, and we know that we can cross multiply here, or we will just be switching the positions of DC and the tan of 16. So I'm going to leave that in that form because when I put it in my calculator, I'm going to round at the very end. So that's a partway example, a partway solution here. So now we're going to do the other triangle, which is this big, long outer one. I should have picked a different color for this, right? This big, long one. Okay, so what am I going to be finding in that big, long triangle? ACB. This side's still the same, the right angle the same. My angle of elevation is 7 degrees to the top of that lighthouse, and I'm finding all of AC now, right? That's part way, and once I get these two answers here, we're going to subtract them. So now I want all of AC, and I'm going to be using tangent again. Tan of 7 degrees equals the opposite 125. over the adjacent AC, which I want to know. And again, we're going to switch the positions of these two things. AC equals 125 divided by the tan of 7. And so I said that I want to subtract this answer and DC, and if I do that, subtract the bigger one from the smaller one or the longer one from the shorter one, then I should get my answer for AD. So let's do that in our calculator. So 125 divided by the tangent of 16, and I want to do 125 divided by the tan of 7. Okay, that one was larger. That was my longer one. So from that answer, I'm going to scroll back up in my calculator. I'm going to bring that smaller answer, that smaller side down, 582.1. So to the nearest foot, 582 feet is how far that ship has traveled. Go back up to the question. Did I find it? Does it make sense on my picture? It does. So that would be it for that example.